Hello 30-1s, and welcome to Lesson 3 in Polynomials, the factor theorem. Last lesson was about the remainder theorem. And what we will see is that the factor theorem and the remainder theorem go perfectly together. In fact, I've always kind of wondered why some textbooks break this up into two separate things, when to me, they're actually the exact same thing. I'll show you what I mean. Let's take a look at this polynomial here. Px is equal to x cubed plus 2x squared minus 6x plus 8. When we're trying to graph these without a calculator, what I want us to think about is one of the key elements is finding the coordinates of these x-intercepts. So, going back to the remainder theorem, what I would do here is I would list my potential zeros by looking at my constant term. So my potential or possible zeros of p at x are all of the factors of 8. Now, what I can see by looking at this graph is I already have that x-intercept here. Okay, well, to show that to me, what you're going to say is this. I'm going to say, what would happen if I chose one of my possible zeros, this one right there, and subbed it into my polynomial? So I'm going to let x equal 4. So I sub it in, and guess what? This will end up being 0. What does that tell us? Therefore, x plus 4 is a factor of p at x. And if I know the factor, therefore, an x-intercept is -4, 0. That's it. That is what the factor theorem is telling us. If we end up with a remainder of 0, we have a factor. And if we have a factor, we have an x-intercept. If our remainder is anything but 0, we don't have a factor, and we have another point on our graph someplace else. That's it. Easy as that. So, I want to do just one more question with you here. A very, very common one that we see on our diplomas all the time. It goes something like this. It says, given a function, and I'll keep it simple. I'll just stick with a quadratic from grade 11. Given a function, p at x is equal to, let's say, x squared plus, let's say, kx, and what's a good number here? 8. Has a factor of x plus 7 what is the value of k? Okay, so given a function p at x is equal to x squared plus kx plus 8 has a factor of x plus 7. Oh, I'm going to change that to say x plus 8. What is the value of k? All right, this is what this is telling us. We've got some polynomial here. It's opening up. And it does something, I don't know, who knows, something like this, like that. Okay, and it's saying to us it has a factor of x plus 8. Well, if this is my factor of x plus 8, what that tells me then is, therefore, we have an x-intercept at -8, 0. Okay, over here. So how does that help me find k? Well, what we're going to do then is if I want to find k, that means I have to know x and y. So I'm going to rewrite our polynomial with a y instead of an n, p at x. If I want to know k, I have to know x and y. So what am I going to do? I'm going to sub in this point, negative 8, 0. This is really us using the factor theorem. If I sub in negative 8 into this function, if I sub in negative 8 into this function, I will get a remainder of 0 because it's a factor. Okay, let's go and find k. Negative 8 squared is 64, minus 8k plus 8. I'm going to add 8k over is equal to 72. So then k is equal to 9. That's it. That's what that question's asking for. Now, I'm going to check my work really quickly. So to check my work, what I'm going to do is I'm going to say, listen, here was the polynomial then. X squared plus 9x plus 8. Well, guess what I can do from here? I can factor this thing and quickly make sure that the information I was given matches. Sure, it said there's one of my factors. If I don't want to factor that thing, I could always just graph this in my calculator and verify that the information matches. All right, friends, that's it for factor theorem. Again, the factor theorem is simply telling us if we sub in a value into our polynomial and it gives us a remainder of 0, you just found an x-intercept. That's it, that's all. All right, I hope that helped. See you next time.